When we were starting to work on Cytogen, I would say the field had kind of stalled out at a limit of about 18 to 20 colors. This is our R&D lab. By manipulating the chemical structure, we want to create unique colors that we can identify through our cell sorters or cell analyzers. You know, it really came down to this idea of we need brighter colors and more of them. And it was like, well, we can do that.
I can literally remember the first time I had the meeting with the Cytogen people, and I looked at the data and it's like, oh, this is a game changer. If you're doing a biological experiment, you have to identify which are the markers that you're going to use to identify the population.
Because of your measuring techniques, you're only able to see the world in a certain way. When you add more tools and more capability, you really change the way you look at biology and look at the world. R&D scientists will start by putting together different building block components to make different polymeric structures. That's what we work on kind of day in, day out. The field has really evolved, really in conjunction with the advent of new dye technology.
Each one of these can detect up to 10 different colors.
So we launch the emitted light into the fibers, and then it comes down the line and gets into the detector. The bottom line is we're trying to make a good tool for our customers, a good solution as a total, we're not just building hardware, we're building a complete system. That means they're merging into the drop that's following it.
As new dyes were created, people could take on newer and more complex applications for flow cytometry and cell analysis. So this is BB421. This is the first product we made from Cytogen that was commercialized. It was 10 times brighter than the incumbent dye. We're able to move things up and down the visible spectrum from ultraviolet up into the near infrared.
Each of these is the equivalent of like a separate laser. So when we make a new reagent, we want to see what instrument it works on and how well it works on every instrument. Everything is a marriage of the biology, the reagents, and the instrumentation. The idea is to make things simpler, to make it easier for the customer.
As we develop new dyes, we're interested in looking at all these channels and the quality of the data coming off of each of these channels or lasers as well. So,
yeah, this is the Ferrari of flow cytometers right now.
Propelling that science forward into new discoveries and identifying new disease states and how that might translate, particularly in areas of like cancer, continues to be highly motivating and keeps us going every day.